So radioactive decay and half-life are related. If you're taking chemistry, or have taken chemistry, you probably are somewhat familiar with this. What we're doing is we're losing material at some rate, and when we're talking about half-life, we want to find out when half of it's left. So for this, since they gave us this equation, and we're looking for the half-life, if we start with 100% of the material, and it's decaying at this continuous rate, that's the continuous rate. We want to know when there's 50 left. Well, with half-life, I really would like you to learn this shortcut. If I divide both sides by that initial amount, that's 1/2, and that's why it's half-life. We're looking for when there's half left. So for any time we have a half-life problem, you can always ignore the initial amount, replace this with a half, and then it's pretty easy. You're just going to take the natural log of both sides, divide by that, and that'll unlock the exponent there, right? And grab your calculator and crunch it. And you wait just a minute here. And there's that answer. Wasn't that slick? So the half-life is now about 19¼ days or hours or whatever the unit is. They aren't telling us. Okay? So that's one part of it. That's pretty easy. Actually, you've done a little bit of this year already, earlier. Now, the other aspect that comes into play in this textbook and some of the questions I'm going to ask you are the difference between continuous rate and annual rate or daily rate. What it does, it depends on the time. And the first couple here, we're just going to deal with it if it was an annual rate or a daily rate. We aren't going to worry about having to see how many decaying periods happen in a time period. We're just going to take it as one shot. So if you think back to what we did back a couple sections ago, I had you change an exponential growth or a continuous growth problem into a annual growth problem. Okay, and that B was the same as 1 plus R. Okay, so another way of writing that second equation was like this. And what I had you do, and what the textbook had you do, was you had to raise e to the k and ask yourself when that was equal to b. Okay, and that's what we're going to do here. If I was in the next question, I'm going to have you do, ask you to find, hey, here's the half-life, find the continuous rate or the annual rate, I think is what it says. So what we're going to do is, since we know that we have a half-life equation that looks like this, or we have an exponential equation that looks like this. Okay, we want to know when does e to the negative 0.036, because both of these equations have a t, right? So it must be those bases are the same if the initial values are the same and the time periods are the same. Okay, so we can say e to that exponent has to be equal to b. Well, we can just grab our calculator, raise that to that power, fire mine up. So we're going to take e, raise it to the negative 0.036, and that'll have to be what b is. And since I know that the b, the base, is equal to 1 plus that rate, I know that 0.9641 equals 1 plus r. So subtract 1 from both sides, And that will be what my annual growth is. And what is that? 0.036. I'm losing it in my head here. So it's 1 minus that answer. So 0.03. And we can say it's losing material at 3.6%. We can say it's a negative 3.6%. Okay, so and that's that. So that's going to be the annual, or however many. We aren't told if this is annual or daily or what, but okay. So that's the process of finding the half-life and find the annual rate and the continuous rate they gave us. Okay, this next problem then is kind of just like what they told us. They told us the half-life is 10 days. Okay, so they're asking us to find the daily rate. So we're going to pretend that daily rate is just the annual rate. So we aren't going to have to do anything too tricky with this. So the first part of this process is you're going to have to find the k, right? Remember, we know that 1/2 has to equal e to the k t, and since we know t is 10, okay, to find that, we can just take the natural log of both sides and divide it. I'll let you do that and find out what that k constant is. That's what I got. Okay, so that's the continuous growth rate, because that's we used E. And then to find the daily rate, we're going to pretend it's an annual. You're not doing anything too fancy with this. So do you remember what we're going to do? I'll let you think about it for a minute. Stop it if you need time. So I'm going to say e is raised to that power. And that's what I got when I'll just get rid of this so that you guys can see the whole answer. Okay. And that's how I got that daily rate. If I had to use this equation to make a prediction, like how much is left in 20 days, I mean, I could use either equation now, and what I would do is I wouldn't have to do anything too fancy. I'd have to say 100 times e to the negative 0.0693 in 20 days. I'd stick 20 in for t and then crunch out on my calculator. Okay, so I hope that helps.